Okay, the third gas law we're going to talk about is the combined gas law. So Boyle's, Charles, and actually a third gas law that we're not going to talk about, it's the Gay-Lussac's gas law, can be combined into a single law. And the combined gas law states the relationship between pressure, volume, and temperature. So we've already talked about the pressure-volume relationship, the volume-temperature relationship. So now we're going to put these three things together. And these variables are going to have the same relationship to each other in the combined gas law as they have in their individual gas laws. So pressure is going to remain inversely proportional to volume and directly proportional to temperature, and volume is going to remain directly proportional to temperature in Kelvin. So that's going to give us our P1 V1 over T1 equals P2 V2 over T2. So you can see that this portion of the gas law looks like Boyle's law, and this portion of, it's not a very good color, try that again. This portion of the gas law looks like Charles's law. So gas at 110 kPa and 30 degrees Celsius is going to fill a flexible container with an initial volume of 2 liters. If the temperature is raised to 80 degrees Celsius and the pressure is increased to 440 kPa, they want to know what is the new volume going to be. So same rules are going to apply here. Your pressure volumes need to be the same, temperature volumes need to be the same, volume units need to be the same, and temperature has to be in Kelvin. So the first thing we're going to do is convert our Kelvin units, our Celsius units to Kelvin. So that's going to give us 30 plus 273 is going to make 303 Kelvin for this one, and 80 plus 273 is going to be 353 Kelvin for our second one. So now we can go and identify our variables. So we have 110 kPa, and kPa is a unit of pressure. 303 Kelvin. Kelvin is a unit of temperature. We have a flexible container, initial volume of 2 liters. Liters is a unit of volume. And since this is our initial volume, that means that these are going to be our initial values. So our temperature is then raised to 80 degrees Celsius, which is 353 Kelvin. So this is going to be our T2. Pressure is increased to 440 kPa. So this is going to be our P2. And we are looking for V2. So now we can write our original equation. P1 V1 over T1 equals P2 V2 over T2. And we are solving for V2 here, so we need to get that guy by itself. So you can multiply out the T2 to get rid of it. And we can divide out the P2 to get rid of it. So now we can plug in our variables. So we have T2, which is 353 Kelvin, times P1, which is 110 kPa, times V1, which is 2 liters, divided by P2, which is 440 kPa, times T1, which is 303 Kelvin. So to make sure you have this set up right, double check your units, and they should cancel. So we have Kelvin over Kelvin that cancels. We have kPa over kPa that cancels. And we are left with liters, which is what we are looking for here. So We have set it up correctly. So now you can do the math. 353 times 110 times 2 divided by 440 times 303. And we're going to go with 3 sig figs here. And that's going to give us 0.583 liters. And remember we said when pressure increases, the volume is going to decrease. So our answer makes sense.